Good afternoon, everyone. In lecture number 2 of metallurgy, we are going to discuss about the concentration of the ore. In lecture 1, introduction of metallurgy, we have covered about the extraction process, how to extract the metal from the ore, and the three basic steps which were involved were concentration of the ore, reduction of the ore is the second step, and the third one is refining of the ore. So in the first step, that is concentration of the ore, we have different methods of concentrating the ore. The different methods are hydraulic washing, froth flotation, leaching, and electromagnetic separation. So in this concentration of the ore, as I have already discussed, concentration of the ore is nothing but we are removing the earthy impurities, or we are removing the gangue particles. We are separating the gangue particles from the ore is nothing but the concentration of the ore. So this concentration of the ore is also called as ore dressing or benefaction. So we have different methods of concentrating the ore. These all different four, we will be discussing about all these four methods, and these four methods, depending upon the type of the ore, the method has been chosen. So now we will be discussing in detail about all these four methods. Okay, the first one is hydraulic washing. Okay, now we'll be discussing about hydraulic washing. In hydraulic washing is the first technique which is used for the concentration of the ore, and the basic principle which is involved in hydraulic washing is the density difference, or it is the gravity separation, which means that the heavier metals, here metal or the ore which is containing the gangue particles associated with it, the gangue particles are lighter, and whereas the metal particle is heavier. So that type of metals can be separated by using hydraulic washing. So in this hydraulic washing, so the basic principle is the density difference or the gravity separation depending upon the mass differences between the gangue particles and the ore particles will be we will be separating our required metal. So it is useful. So the second point is nothing but it is useful for the ores of heavy metals like tin, lead, and iron. These are the heavy metals generally. So the ores containing tin, lead, and iron can be separated by using hydraulic washing. So if you take the disadvantages, hydraulic washing is only applicable for heavy metals, but the lighter metals cannot be separated using hydraulic washing. Okay. So now, if you see this hydraulic washing process, how does the process takes place? We will concentrate on the procedure of hydraulic washing. In this hydraulic washing, we have a hydraulic classifier. So this is what is like, it's like a funnel. We are adding, what we are adding? We are adding crushed ore. We are adding crushed ore. Crushed ore is nothing but we are making it into a fine powder or into a fine mixture. Both the ore and the gangue particle made into a fine mixture is passed through the hydraulic classifier. And this is the pipe which shows that the passage of jet of water onto the crushed ore. So what is happening when this jet of water is passed onto the mixture of crushed ore? What is happening? The heavy ore particles will settle down on the platform. You can see this is the platform. On this platform, the heavy ore particles will be settling down. Since they are not lighter in weight, they will not carry away by the water. Whereas the lighter gangue particle will move along with the water. So this is how we can see that on this platform near this wedges, we have the heavy ore particle settling down here bottom, whereas the lighter gangue particle will move along with the water. So this is the schematic diagram of how the hydraulic washing process or the technique takes place, and the separation of the heavier ore particles like tin, lead, and iron are separated using the jet of water flow through this platform. Okay. So the second method of concentration of the ore is froth flotation. So froth flotation, this is a very important method for which is used for the concentration of sulfide ores. Mainly it is used for the concentration of sulfide ores. So that's why it is important for you to remember the froth flotation process, which is mostly asked, which is mostly important from the examination point of view. So in the froth flotation process, if you see, it is used for the sulfide ores. Sulfide ores like copper sulfide, zinc blend ZnS, iron pyrites FeS2, and lead sulfide, that is Gelina. So all these sulfide ores can be concentrated using the Froth flotation process. So what is the technique used here, which is making only sulfide ores to be concentrated by the process of Froth flotation? Is here it is based on the principle. So while we are discussing about the procedure of this Froth flotation, you'll understand why only sulfide ores are concentrated using Froth flotation process. So since here we have in the sulfide ores, the metal is combined with the sulfur. Sulfur has the ability, sulfur is a larger atom, so it has the ability to wet by the oil. So here in Froth flotation process, the procedure involved is we are taking the powdered ore, which is mixed into water as well as oil, in which the sulfide ore particles are wetted by the oil, whereas the gangue particles which are present along with the ore, these gangue particles are wetted by the water. So here, if you see the diagrammatic representation and the demonstration of this experiment, you will understand much clear. So now we will see the diagrammatic representation. So the diagrammatic representation will make you understand the concept much better. So this is the view of Froth flotation process. So if you see the diagram here, we have taken a beaker like a tank, in which we are adding a powdered ore. So the powdered ore is added into a tank which contains water and oil. So here we are mixing water as well as pine oil. So here what happens, as we know, water is more denser when compared to the oil. The water will settle down, whereas the oil will be in the up of the tank. So what is happening when we add powdered ore here, due to the difference in the wettability of sulfide particles and the gangue particles, sulfide ore particles will be wetted by the oil, whereas the gangue particles, that is your earthy materials, mud, sand, silica, everything will be wetted by water. So what is happening? We are also sending compressed air through a pipe, which will allow the froth for the generation of the froth. So we are also adding some froth stabilizers as well as collectors here. So the froth stabilizers are, we are adding pine oil. Pine oil, what happens when we add pine oil into the beaker? First we have taken water into the beaker, and then we have added pine oil. After mixing the mixture, now we have added powdered ore. After adding the powdered ore, what is happening? Due to the difference in the non-wettability properties of sulfide ore particles and the gangue particles, sulfide ore particles will go along with the oil, whereas your gangue particles, which are the mud, which is a earthy material, it will settle down at the bottom of the flask along with the water. And this compressed air is sent because it allows the continuous agitation and the flow of froth from the lower part of your region to the upper part. So you can see the bubbles here. If you see the froth bubbles carrying the sulfide ore particles, here you can see this is a froth. If you keenly observe, you will be having a bubble in which this is the froth which is generated, and we are having the ore particles which are associated with that bubble. So, and the gangue particles are settled down at the bottom of the tank. So here the most important points in Froth flotation you have to remember is that we are adding pine oil, which is the frother. Here it is generating some froth or foam. What is froth or foam? When you add surf into water, you will see the bubble formation. So that is called as froth or foam. So froth or foam is generated by adding pine oil and sending compressed air for agitating the mixture. So that is how you are getting this froth bubbles. And then we are also adding collectors. The collectors used are potassium ethyl xanthate. Why are these collectors used? These collectors are used to see that there is no wettability of sulfide ore particles by water. Here our main aim is sulfide ore particles should be wetted by the oil, that is a pine oil, whereas our gangue particles should be wetted by the water, and these gangue should settle down and the sulfide ore particles should go along with the froth to the upper part of the tank. And so this is the work of collectors. After collectors we have froth stabilizers. Froth stabilizers generally used are we are using the froth stabilizers as aniline and cresol. What is the work of a froth stabilizer? The name itself says stabilizer is nothing but it is making the froth to be stable. As we can take an example of surf, when we are adding into water, what is happening? That bubbles will come up, but they will not stay for a longer time. So that's why in order to make our froth to be stable, in order to not go away, to make it stable, we are adding froth stabilizers like aniline and cresol. That is the work of froth stabilizers. Okay, so this is how the froth flotation process is used for the concentration of the sulfide ores. So let's see the demonstration of this froth flotation process. I am showing a glass of water here. I don't have a beaker, so I have taken a glass of water. Now, if you see, as I have said you, we are taking water first, and along with the water we have to also take oil. So I'll be taking oil now. So if I show you the oil is present. The oil is present on the upper surface of the water only, because here we know that water is denser and oil is less dense when compared to water. So I have taken little amount of oil only in order to show you how does the experiment work out. So after taking water as well as oil, we will take 2 layers of water and oil in equal mixtures. So after taking oil and water, oil will float on the upper surface and water will be in the down surface. Now what we have to do? We have to add the powdered ore particles into this, and we should also insert a pipe which will send compressed air through this. So when I send compressed air through this, what will happen? It will generate some air bubbles inside it for the agitation of the mixture. That is, the mixture should continuously mix. So what will happen? The ore particles will mix along with the water. The gangue particles are wetted by water and the sulfide particles are wetted by the oil. So what is happening now? You are generating some froth by adding a frothing agent, that is your So this is how the froth will form. So if you see that this is the froth. So this froth is having the ore particles, whereas the gangue particles will settle at the bottom of the tank. So this froth, if you see, the froth will disappear after some time. So in order to make that froth stable, what we have to do? We have to add froth stabilizers like aniline and cresol. So this is the work of froth stabilizer, and here we are also adding collectors like potassium ethyl xanthate. So what is the importance of collector is, what does a collector do? It will allow that, it will see that the sulfide ore particles are wetted only by oil, whereas our gangue particle is wetted by water. And what is happening when the gangue is wetted by water? It settles down at the bottom of the tank, whereas the sulfide ore particles which are wetted by oil, in which the oil is moving upwards of the tank, so there the sulfide ore particles will come to the upward of the tank. So when you remove this froth, what will happen when you separate the froth from the tank? You can see that our ore particles are now free from the gangue. Okay. So I just wanted to repeat the froth flotation process once again. So froth flotation process is used, the first important point is it is used for the concentration of only sulfide ores. Sulfide ores like iron pyrites, FeS2, and we have seen sulfide ores like zinc, blende, galena, all these are sulfide ores. So you have to see that the first important point is Froth flotation is used for the sulfide ores. And how is the procedure taking place, and why only sulfide ores are separated or concentrated using Froth flotation processes? If you check out the process, you will see that in Froth flotation process, in a tank we are taking a mixture of water and oil. So when we take water and oil which is lighter or less dense when compared to water will move upwards, and water which is more denser will move downwards. When we add a mixture of powdered ore into this tank, what is happening? This powdered ore contains both the gangue as well as the ore particles. So the gangue particles here, they have the difference in the wettability. So gangue particles are wetted by the water, whereas our ore particles, which are containing sulfide ore, sulfide metal particle, is wetted by the oil. And we are also sending compressed air into the tank for agitation, to create an agitation in the tank. When that agitation is taking place, what is happening? There is a generation of froth which will move upwards, in which that froth will contain the sulfide ore particles and this water will contain the gangue particles. And we are also adding collectors. Collectors are also second important point is we are adding collectors. First is we are adding water plus pine oil and mixture of powdered ore, and then we are sending compressed air. Then we are adding collectors. Why are these collectors used? How are these collectors used in this process? Collector used is potassium ethyl xanthates. Any xanthates are added. So these xanthates, what do? They will see that there is a non-wettability of sulfide ore particles by the water. Okay, then we are also adding the next agent, that is Froth stabilizers. Froth stabilizers, like we are adding aniline or cresol. Why are we adding Froth stabilizers? These stabilizers will stabilize the froth. As I have said you an example, the froth which is generated due to surf, when we add surf into water, what is happening? The froth or the foam, it will disappear after some time. It is just an air bubble. So that's why, in order to no disappearance of this froth, we are adding Froth stabilizers like aniline or cresol. And after this froth formation which contains sulfide ore particles, we are separating the froth and we are collecting our sulfide ore particles. So the other point in Froth flotation process, which is also again an important point, is we are also adding depressants. A depressant like sodium cyanide is added. These depressants, where are these depressants used is when we add a mixture of sulfide ore. For example, we are adding a mixture of lead sulfide and zinc sulfide, that is galena and zinc blend. What is happening when we are adding a mixture of sulfide ore? Generally, galena and zinc blend are present in the earth crust as in combination. If I want to separate, both the sulfide ore particles cannot be removed at a time. So in that mixture of sulfide ores, what we are adding? We are adding depressant. When we add a depressant like sodium cyanide, what does it do? Only one of the ore particle which is to be removed, like lead sulfide, will come along with the froth, whereas zinc sulfide will form a complex with the depressant what we are adding, that is sodium cyanide. I wanted to show the equation how a mixture of ore is separated using Froth flotation process, that I will be showing you. So in the Froth flotation process, I have said you, this is the froth, collectors ethyl xanthate, Froth stabilizers aniline and cresol, and depressant is NaCl. Why do we use a depressant? In order to separate when we add mixture of sulfide ores. See, for example, I have a mixture of lead sulfide and zinc sulfide, that is galena and zinc blend. I want only one ore particle to be separated. So what is happening? When I add two ore particles as a mixture, I should add a depressant, where this depressant will form a complex with one of the ore particle which is present in the water itself, whereas the lead sulfide which is not showing any reaction with the NaCl will raise along with the froth, and that froth can be separated and can be and thus lead particles can be separated from the froth. Okay, so this is how the Froth flotation process works. So which is a very most important topic in metallurgy, which is used for the concentration of only sulfide ores. So here the questions are, questions will be asked in such a way that they will be giving you the sulfide ores like zinc blende. So you should know the formulas of the sulfide ores which are separated or concentrated by which type of process in concentration of the ore means we have to say it is Froth flotation process, because it is only the Froth flotation process which involves in the concentration of the sulfide ores. Okay, so this completes lecture 2 of metallurgy.